Algebra 2 students, this is part 1 of lesson 12.3 where we are going to learn about geometric sequences in series. In the first lesson we did yesterday, we were learning about patterns where we kept adding the same thing over and over and over again. We called those an arithmetic sequence or an arithmetic series, and there was a common difference in between each term. In this lesson, we're going to see patterns of numbers where when we go from one term to the next, we're actually multiplying by the same thing over and over and over again. We're going to see some different things that happen with those particular sequences in series. So, to begin, definition: in a geometric sequence, the ratio of any term to the previous term is constant. Now, ratio means to divide. This constant ratio is called the common ratio and is denoted by the letter R. Again, you have these notes and you can be jotting these things down as you go. So first off, we're asked to tell whether a sequence is geometric and then explain why or why not. If I want to find out if a sequence is geometric or not, I might be able to just tell it by looking at it. I might be able to notice a pattern of repeated multiplication. The other way that I can check is I can use the definition. Now, it said there's a common ratio, which means that each time if I were to divide one term by the term right before it, I would get the same thing. Let me show you what I mean with this first example. In this first example, we have 2, 7, 12, 17, 22. Now, you can probably obviously pick out that we're adding 5 each time, and you would say, well, that's an arithmetic sequence, not geometric. Well, let me show you how you could also test it if you weren't sure. If I'm not sure, and I want to know if it's geometric or not, I'm looking for a common ratio. So I would take the second term, 7, divided by the first term, which is 2. And then I would take the third term, 12, divided by the term right before it, which is 7. Now, these numbers are not equal to each other, so I already know that this is not going to be a geometric sequence. We'll go ahead and say no to that one. With the second example, 2, 6, 18, 54, 162, you might notice right off the bat that I think to go from 2 to 6 and 6 to 18 and 18 to 54, I think that we're multiplying by 3 over and over and over again. If you saw that, you'd be right, and you could say, yeah, this is a geometric sequence. Now, to test it according to the definition, again, just to show you how this would work, we would take the second term, 6, divided by the first term, which is 2. And then I would take the third term, 18, divided by the term right before it, which is 6. And then I'd take 54, divided by 18, and so on. And notice that each time I do this, so 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. So I'm going to go ahead and say that, yes, this is a geometric sequence, and it has a common ratio of 3. Now, next thing. Again, when I'm asked to write a rule for a geometric sequence, similar to when we had to write a rule for an arithmetic sequence, there's usually a particular pattern that we're going to follow. Now, the rule that we can follow for a geometric sequence is as follows. For the nth term of a geometric sequence with a first term of a sub 1 and a common ratio, we can write it this way. We're going to take a sub 1, the first term, and multiply it times r, the common ratio, raised to the n minus 1 power. So the key is that I'm subtracting 1 from that exponent. So in other words, if I were to find the second term here, 6, I start with the first term and I multiply by the common ratio of 3, but I only do that once. Okay? If I want the third term in the sequence, I'm going to multiply by 3 twice. So similar to the arithmetic sequence where we added the common difference n minus 1 times, here we're multiplying by the common ratio n minus 1 times. For an example with some numbers in it, the nth term of a geometric sequence with a first term of 3 and the common ratio of 2 will be given by something like this: 3 times 2 raised to the n minus 1. Now, typically we'll put the ratio in parentheses, or we'll put a multiplication symbol in between those two, and understand that we don't multiply the 3 times the 2. As you think about order of operations, exponents come before multiplication, and this n minus 1 exponent only applies to the 2, not to the 3. So if you were to multiply 3 times 2 and have 6 to the n minus 1, you would be incorrect. So there we have a rule for a geometric sequence. Now, practicing with a couple of sequences down here. Our first sequence, we're asked to write a rule for the nth term and then find the 6th term in the sequence. Well, as I look at this, first I'm going to find the common ratio. And I do that by dividing a couple of terms just to make sure it's geometric in nature. Well, 12 divided by 3 is 4. 48 divided by 12 is 4. I'm pretty certain that this is going to have a common ratio of 4. Now, the other thing I need to know as I write this, notice there's 2 things. I need to know the first term of the common ratio. Common ratio was pretty easy to find. First term is even easier to find. It's 3. If I know those two things, I can go ahead and write my rule. My rule will be, for the nth term, 3 the first term times 4 the ratio raised to the n minus 1 power. That's it. Nothing else to do to simplify it. There it's written. I was also asked to find the 6th term in this particular sequence. Well, to do so, I plug in 6. 6 minus 1 is going to be 5. 4 to the 5th power times 3 is going to be 3072. I cheated. Don't think I did that in my head. Next, 36, negative 12, 4, negative 4/3. Well, let's figure out what's going on here. Again, two things to know. The first term and the common ratio. Well, the first term is obviously 36. Our common ratio, a little bit tougher. Let's see here. Let's take the second term, negative 12, divided by the first term, which is 36. Well, if you simplified that, that would be negative 1/3, right? Now, I think that's what the ratio is going to be, but I'm going to check one more time. What if I take 4, the third term, and divide it by negative 12, the term right before it? Is that also negative 1/3? Yes, it is. So I'm pretty confident I can say that negative 1/3 is going to be our common ratio. And it's okay to have a fraction, or a negative number too. Once we know these two things, we can write our rule. The nth term is going to be equal to the first term times the common ratio raised to the n minus 1 power. And if I want the 6th term in this particular sequence, I plug in 6 here. 6 minus 1 is 5. Negative 1/3 to the 5th power is going to be negative 243 times 36. It's all going to simplify now to negative 4/27. And again, I know that's fast, but I know you can type that into your calculator and evaluate that just fine. And that's the end of part 1 of lesson 12.3.